principles that I thought would be good to know about based on the studies that we are talking about today. So just as a recap, thinking about it from the methodological perspective, for the first paper, I think if we were to summarize it in one question, we would say among those with ischemic cardiomyopathy who undergo CABG as compared to receiving medical therapy only, to those who have myocardial viability have better outcomes than those who do not. And as for the second question, what we're asking is among those with ischemic cardiomyopathy and myocardial viability, does PCI improve outcomes? So thinking about these questions, how then do we go about the statistical methods? So I think if we were to zoom in on the methods section for the first paper, you can see some of the keywords that I've highlighted here, which is basically them doing comparisons of the incidence of death from any cause. And this was performed with the use of multivariable Cox proportional hazards models that were adjusted for relevant baseline covariates, and survival curves were generated with the use of a Kaplan-Meier estimate. If you zoom in at the statistical methods for the other paper, we see that they did unadjusted time to event analyses to evaluate outcomes. And you see it also says the primary analysis included data from each patient up to the date of the outcome event, last follow-up visit, or withdrawal of consent. Hazard ratios with 95% confidence intervals were calculated with the use of a Cox proportional hazards model, and cumulative incidence was calculated with the use of Kaplan-Meier estimates. So what I'm driving at really is this theme of using Cox proportional hazards model and a Kaplan-Meier estimate, and this is what we'll focus on today. And whenever we see a term such as Kaplan-Meier estimate, we expect to see a survival time graph like what we see here. And I would take you through some of the basic concepts related to that today. So this brings me to the concept of statistical reasoning, meaning that if we were researchers or critical appraisers looking at a journal, how do we make sense of the statistical methods used? Or in other words, if we were to design a study, what do we understand of the value of some of the models used and how do we apply it? Okay, so for today, we would like to focus on this core question, which is what is a multivariate Cox regression model? What is a survival time or Kaplan-Meier graph? And what does it actually mean in terms of the results, in terms of how we talk to our patients or discuss the result or the impact of the paper with each other? So as an introduction to regression methods, one simple phrase or line that can explain it would be that a regression provides a framework for comparing means, proportions, or incidence rates between two or more groups, depending on what our outcome of interest is. And this, therefore, can be done through linear regression models, logistic regression models, or Poisson or Cox proportional hazard models, respectively, depending on the outcome of interest we're looking at and what kind of a variable it is. So when we say simple regression models, we therefore just refer to analyses with only one predictor of interest, whereas multiple regression models refer to analyses with multiple predictors or covariates. So I think by looking at this, then we recognize that in most of the statistical methods sections in papers that we read, they will start off talking about the outcome of interest that they define, and then the application of a regression model that starts with the simple and then the multiple regression model that corrects for covariates, or in other words, confounders. And therefore, if we're talking about this framework, what does it actually mean? So this brings me to the concept of the regression equation. And if you recall from algebra or perhaps secondary school math, we have this equation y equals mx plus c, which refers to a two-axis and then a line that has a gradient that is the function that links two variables. So this is essentially the basic structure of regression models. This is a linear equation, and basically the function of the outcome is the y, and then with the intercept plus the slope multiplied by x1, which is the first covariate, for example. Okay, so this is the mathematical notation that we might use to describe it. So x1 is our predictor of interest, basically the exposure or the outcome, the variable that we might want to change. And the right-hand side, B0 plus B1 over B1 times x1 includes the predictor of interest x1. The predictor of interest can be continuous, binary, or categorical, as I alluded to earlier. And then the slope B1 is actually the change in the left-hand side corresponding to a unit increase in X1, meaning for every unit change in our covariate, for example, whether a person is male or female, or whether there's myocardial viability or not, what is the change that we expect in the outcome. And that is actually the coefficient. So left-hand side depends on what the variable type outcome of interest is. So when we're talking about Cox regression models, it's basically the name of the kind of equation we have when we have time to event outcomes, where the individual event and the centering times are not known. So Y is a yes/no indicator of whether the event has occurred in the common follow-up period. And the left-hand side is actually represented by a ln incidence rate, and the regression type is a Poisson regression. And for time to event outcomes where the individual event and centering times are known, Y is the outcome taking into account both the time and whether the regression type is a Cox and whether the event occurred. So similarly, it's a ln function. In the interest of time, I'll just quickly show you that this is the equation. And when we look at it, what it means is that the exponentiated slope is the estimate hazard ratio of the